There are a few rules that we need to consider when we combine transformations, but let's have a look at this first. This is what we call transformational form. I'm going to put that there. Transformational, form. In order to talk about transformations, we need to have our equation in transformational form. So it needs to look something like this. Y equals, this negative is in parentheses because maybe you have it, maybe you don't. But if you're going to have a negative, that's where it could be, or here. And then A, F of B, and then in brackets, X minus H. There's a mistake there, isn't there? Do you see the mistake? Let's see if I can fix it. That looks better. It should be plus K. I just had a K there without the plus. So here on the side, you can see I have all the different names of the transformations. I want to put them in place for where they go in the equation. So I have reflection in the x-axis. Which part of this equation describes a reflection in the x-axis? So how do you know if you are going to have a reflection in the x-axis?
A negative on the outside.
A negative on the outside. So right there, that negative, if it's there, there's a reflection in the x-axis. So how about the reflection in the y-axis? How do you know if there's a reflection in the y-axis? So a horizontal reflection. Sorry? Before the x. A negative before the x. That negative would mean that there would be a reflection in the y-axis if that negative is present. See what else I have here. I have horizontal translation. Where should I put that? Above what letter? H. If you have a number, subtract it from the x. Could look like addition too, right? But if you have a number subtracted from the x, then you have a horizontal translation. How about this one? Whoops. Vertical stretch. Where's the vertical stretch go? Which letter? A, right. A number in front of the function stretches it vertically. Horizontal stretch, B, and the last one, a vertical translation, is K. So when you look at a function that's in transformational form, which we're going to do on the next slide, you should be able to say, does it have a reflection in the x or y axis? Does it have a vertical stretch, and what's the stretch factor? Does it have a horizontal stretch and the stretch factor? And then does it have a translation, which direction and by how far? At the bottom here, I have a mapping rule for the function, which we're going to use as well. If you have a function in transformational form like this, x, y maps to, you might have a negative 1 over b. It has to go in the mapping rule as the reciprocal. X plus h, and then negative ay plus k. We're going to use that when we look at the next one as well. I'm going to just write it on the board so we can refer back to that if we need to. These are the things that some of the things that we need to be able to do with transformations. Describe the transformations, write a mapping rule, make a table of values so that we can make a graph. So we're going to do those things for this function. Y equals negative 2, 1/3 x squared plus 1. Does that look to you like it's in transformational form? Do you think it's in transformational form? I think it, like I said, I think it is in transformational form. Y is by itself over here. Numbers in front, plus 1 at the end. All of that looks good. What type of function is this going to be? Quadratic. It's quadratic, right? So what shape is it going to make when you graph it? A parabola. Let's start doing some of these things. Number 1 asks you to describe the transformations. This is where you're going to talk about what's happening to the graph. Can somebody just tell me one of the transformations? What do you think, Tristan?
Horizontal stretch of 3.
Horizontal stretch of 3. So just ask for 1. A horizontal stretch of 3. Do you guys see that? It has a 1/3 in front of the x. So we're going to say that as horizontal stretch by a factor of 3. There's one transformation. Can anybody give me another one? Mackenzie, what is it? So what do we call that transformation? Vertical translation. Up 1 unit. Okay, there's another one. Another transformation. Vertical stretch by a factor of 2. Okay, we'll put that one in. Any more? Yes, what else? Vertical reflection. We usually just say reflection in the x-axis, but it is a vertical reflection. Reflection in the x-axis. Did we get everything? 2, 3, 4, 1, 2, 3, 4. This is good, but there's a problem with what I have written here. Anybody know what it is? Some of you might because you took the course before. It's not in the right order. When we talk about transformations, they have to be in a particular order.
Reflections in the then stretch, then translation.
Reflection, then stretch, then translation, RST. Actually, the reflections and the stretches don't matter. The translations have to come after those though. But usually we do it reflection, stretch, translation. So if I just move this up and I'll move that down, reflection, and then stretches, and then translation. The reason that it's important is if you translate a graph and then stretch it or reflect it, it's different than doing the reflection or the stretch first. And I'm going to show you that so that you understand. So there's number 1. Number 2 asked us to write a mapping rule. And I wrote here on the board the mapping rule from the previous slide, so we could try to do that. Let's see if we can write a mapping rule. So this was number 1. Number 2. X, Y maps 2. We need to figure out how to take all of this information and put it into the mapping rule. So the first thing we're looking at is the X value. There's only going to be one change to the X value because there's only one thing inside those brackets. And it's the 1/3. How does that show up in a mapping rule? 3x. And then there are a few things happening to the y. 3 things actually. There's a negative in front of it. That just shows up as a negative. There's a 2 in front of it. That just shows up as a 2. And then there's a +1, and that just shows up as a +1. That's easy enough. There's the mapping rule. So what would we use the mapping rule for? Finding points on the transform function. Yeah, on the graph, right? If you wanted to sketch a graph and you didn't have a graphing calculator of this, or if you didn't have it defined as a quadratic but some other function, you'd need a mapping rule. Or sometimes you just want to know, where did one point go? So let's look at just one point. What would be one point that's on y equals x squared? 2 and 4? Okay, let's look at where 2 and 4 would go with this mapping rule, and then we'll check it by graphing with a calculator. 2 and 4, which is a point on y equals x squared, will map to 3x, so that's 6. And then negative 2y plus 1. So negative 2 times 4, that's negative 8 plus 1, negative 7. So 6, negative 7 should be a point on the transformed function if we did our mapping rule correctly. Here's the graph of y equals negative 2 times 1/3 x squared plus 1. And does it look like it goes through 6, negative 7? 6 is there, negative 7, right there. 6, negative 7. So the mapping rule was right. If it works for one point, it probably works for all of them. The only one that I wouldn't necessarily test is the origin, because sometimes funny things happen when you're using zeros, right? So I wouldn't test the origin. Actually, I wouldn't test the origin, but I probably also wouldn't test an intercept, like an x-intercept or a y-intercept, because sometimes with zeros, funny things happen. But if you test some other point, you should be able to see if your mapping rule was correct. And it looks like it was. Same 3 things I want you to do here, which were describe the transformations, write a mapping rule. Was there something else? Were there only 2 things? And make a table of values. We skipped that. We only did 1 point. That's okay. We did 1 point. Is this one in transformational form? No, it's not. Does anyone know what's wrong with this one? It's okay that there's absolute values. It's the negative x plus 2, right? The problem is inside that absolute value sign. To be in transformational form, the stretch has to be separated from the reflection, the stretch and reflection have to be separated from the translation. So the first thing I need to do with this one is factor the part that's inside the absolute value sign. So it changes into y equals 3 absolute value negative, and then open a bracket, and we're factoring out a negative 1. So this becomes x minus 2 minus 4. That's really important, and that is one that I want you guys to prove me wrong here, but I can almost guarantee that a bunch of you are going to make that mistake on the test and not factor things out, because it happens every time. So I don't want you to make that mistake. You can try to prove me wrong, but I can pretty much guarantee that some of you are going to make that mistake and forget to factor it out. It's not in transformational form unless the translation is by itself with the x. So that translation, negative 2, is now the only thing that's in the innermost bracket with the x. That's in transformational form. But if the x has other things with it, then it's not transformational form. So then we want to describe the transformations. Which ones should we talk about first? Reflection. What kind of reflection does it have? Horizontal reflection. So a reflection in the y-axis. What else does it have happening here? What should we talk about next? We talked about the reflections. Stretch. What kind of stretch does it have? Horizontal or vertical? Vertical. By a factor of 3. And then we can talk about translations. So it has a horizontal translation. Two units. What direction? To the right. Because it's x minus 2, it's moving to the right. And then a vertical translation. Four units down. So when you talk about those translations, I don't want to see vertical translation negative 4 units. The negative is telling you the direction. So don't say a vertical translation of -4 units. Say a vertical translation of 4 units down. Not -4 units down or -4 units. Leave the negative out. Down means negative. And then we can write a mapping rule. X, Y maps to, what's happening to the X? There's the negative in front of it, which just shows up as a negative. The B value here is 1, so there's no stretch factor, so we just leave that off. We go X plus H. What's the H value here? 2. So X plus 2. And then 3y minus 4. It's a little bit weird. You do have to be careful with this mapping rule. Like the negative is not factored out when you put it in a mapping rule. And make sure you take the opposite sign of the translation, the horizontal translation. So then we can test a point or two. What's a point that would be on the parent function here? What is the parent function? Absolute value of x. So what would be a point that's on the absolute value of x? 1, 1. Okay, let's test that one. So I'm not making the whole table of values. I'm just going to test 1 or 2 points. If I use the mapping rule, x is 1, and that maps to -x plus 1. So -1 plus 2 is 1. And y was 1, and it's 3y minus 4, so 3 times 1 is 3 minus 4, -1. So that point 1, -1 should be on the graph. And it is right there. I want to just test one more. Another point that's on, let's pick one that's on the negative side of the parent function. -1, 1. So -x plus 2 then would be 1 plus 2, so 3, and 1 we already know goes to -1, so 3, -1 should be another point. 1, 2, 3, -1, and there it is. So it looks like the mapping rule is right. It's nice if the function is given in terms of the parent function, so it has the absolute value right in it, or you know what the parent function is and you can graph it on your calculator, because then it's really easy to check. It becomes difficult to check if the parent function is just f of x and you don't know anything else about it. But if you can check with your calculator, then check with your calculator.